Welcome back to Database Forensics, Day 4. Today we are going to continue on how data solves crimes in large organizations against a media. Given that it's a company that had $12,000 overpayment and the payroll shows no anomaly, and the HR department says nothing was exhibited. So how do we go about this? Last week we were talking about deletions. We saw updates, we saw delete, and we saw drop. Today we are going to focus on transaction log. This is more on the back end. Now when the database system is set up for any organization, once a table is created or the database is created, a file, an LDF file is created. An LDF file is created. It is a system inbuilt file, and this file is the transaction log. So generally when you save a data in a database, you think the data is just saved, but the data has to be written first in this transaction log before it is saved in the database. So look at it this way. The transaction log is like the database CCTV footage and the receipt report of the database. So generally in the old days, look at the bank and the bank owner first. You must write every change of money before the transaction is happening, and they never erase anything on the bank note. So if there's an error on the line, the next line they don't use a marker, an eraser. They write it in the next line. And every action that is being taken by the bank teller has to be written on a single line. It's the same with the SQL server. It does the same thing. It does it for every operation that is being carried out in the database system. Maybe the delete operation, the update operation, the truncate operation, one log for one log. And this process is called the write ahead logging, which is the foundation of forensics. The transaction log, this way we are able to trace what happened before we had an overpayment. So if the record is gone from the UI, where do we find it? We simply investigate the transaction log. So the transaction log is an LDF file, a system inbuilt file, the CCTV footage of the database. It shows the records of the data. The records of the data. It has the records of the data before the data is sent to the table. So see the transaction log this way. It's an LDF file. Generally, when you want to save a data to the database, you as in the user interface, you feel like you are just sending the data directly to the database, but it passes through the transaction log first. It is very much sequential. So when you input your request, it is saved in the memory, the RAM memory, and the RAM memory is very volatile. So when it saves in the RAM memory, it is quickly written in a sequential write in the database transaction log. Before once it has been written in the transaction log, the checkpoint at this point now the data now can now where it generally delays, it will now be saved now to the database. So it has to be written here first. Now what makes this very important is that if there's a transaction failure or there's a light failure or there's a short circuit or something, the data, we can always recover the data. It makes the database active compliant. So for every change, one log recorded before that data was changed. For every change, the data must be recorded before it is changed. So we can do redo or we can do undo. For redo, we can do redo complete works, or we can do undo have back changes preventing data corruption. Now it has the image structure. So it shows you the first initial data, which is the row log content 0, which is the old data, and the new data, the content row log content 1, and the time and the user for that data. Now for us to actually implement this, we have to copy model, because the highest problem of a forensic specialist is um, um, truncation of the transaction log. So you have different recovery models. You have a simple recovery model, you have the full production recovery model, and you have the bulk log recovery model. For the simple recovery model, the data that you have to input, the data that has to be sent to the database is sent to the transaction log. But once the data is received in the database, the transaction log is overwritten, it is truncated. But with the full, this is generally a select command, so we don't use it often because you cannot get the data once it is truncated. The data is overwritten. Now with the full recovery model, the data is sequential. It's never deleted. It's sequential. It's never overwritten. It is very much sequential. Every data is appended beneath. Every data is appended beneath, and this is the one that is mostly used by most organizations, by generally all large organizations. It is the only once it is very good in that once there is a regular backup, a custom backup, before now the data can be overwritten, if not if compiling the data. We have bulk log recovery model. So this bulk log recovery model is the same as a full log recovery model. The only difference is that after when there is a massive event, the bulk log will just take a snapshot of that event, but it will not show the line by line code or the line by line record for each event or for each command that was passed during that snapshot. So that is the disadvantage of using the bulk log recovery model. Now, these recovery models and transaction logs can be very effective, and there are things that can make them not to be effective, especially when it comes to investigating or data recovery. For example, if you select a wrong recovery model, the data that is stored in the transaction log is going to be overwritten. If there is a log corruption, for example, like let me say there is a hard drive crash or there was a power outage during the write process, the log can be corrupted. Now, if there is an insider that has a malicious person that has access to the log file, to the LDF file, the person can clear the cache or even delete those log files. And generally, transaction logs are very 99.9% effective for cache recovery and 0 to 50% effective for forensics if it's not managed properly. If, for example, you choose the wrong recovery model or LDF overload files. LDF are visual log files. These are small chunks of because the transaction log is not a single block. It is divided into small chunks which are in circular rows, and these circular rows are the VS files. So if they allow them to accumulate without doing backup to free up space or to mark some as inactive that they can be reused, is going to create a massive amount of data which is going to take a lot of space, creating a system to poorly function that is going to reduce performance. And it is very much 100 effective for point in time recovery. This is generally when you are using full recovery model. Thank you. So see you in the next video in a while.